All right. So yeah, we will need our calculators because what we're basically going to be doing is a few calculator skills with trigonometric functions. So this is applications of trigonometric functions, right? So we have here an entomologist. So that's someone who studies insects. An entomologist is studying a variety of mosquitoes, observes and estimates the population of the colony for 16 weeks. If T is the number of weeks after the initial estimate is made, the population can be modelled by this equation. And we have P of T is equal to 7,000 plus 2,000 sine of pi T on top of 8. Okay, part A says find the initial estimate of the population. So this means what's the population when time is 0? So for part A, all we're doing is we're finding P of 0. When time is 0, what's the initial population? And we'll start with by doing this. Straight onto our graph, I think. So let's pull up our calculators. We'll go to graph mode, and we're going to type in the function. So in our y1, we'll have 7,000 plus 2,000 sine of, and then in brackets pi t or pi x on 8 it's going to be. So we'll type all that in. 7,000 plus 2,000 sine fraction pi on 8. Close the bracket.
Do you need t then?
Yeah, you can't use t on your calculator, so it'll be x. So good question. All right, and then we'll adjust our v window. All right, in order to see it. So we are told that it's modelled for 16 weeks. Now, anytime we have time is always on the x-axis. So that means on the x-axis, we're going to go from 0, from time is 0, to 16. So we have our x-min as 0 and our x-max as 16. All right, so in our v window, sorry, Lincoln. 16. So we're going from 0 to 16 for x.
Does it matter if I'm in radians?
We want to be in radians. All right, and the hint that we want to be in radians is the pi. Anything that involves pi means we want to be in radians. Now, when you have this kind of question pop up in the test, it will give you a Cartesian plane. All right, so it'll give you the v window that we want you to graph it over, just like we have done with previous tests as well. However, we can also work out what an appropriate v window for this will be. So we've established what the x is going to be. For the y, well, the minimum population, the lowest it would be is 0. You can't have a negative population, so we're not going to consider negative values of y. And then as far as the y max goes, well, think of this function, right? The amplitude is 2,000, so that means it's going 2,000 up from the principal axis. And the principal axis is 7,000. All right, that's our D value. This is our A value. So the highest that it's going to go is 7,000 plus 2,000. The Y max is going to be 9,000. All right, or you can go just a little bit above it, but it just needs to be really high. So we've got 9,000, not 90,000, and beautiful graph. And so what that's looking like for me is just up here, and it's just a one wavelength of the population of mosquitoes. Everyone got that? All right, if any issues now? Okay, cool. So now we can answer part A, which says, what's the population when time is 0? So there's two ways we can answer it. One would be to type this into run map with 0 there. Of course, sine of 0 is 0. So the initial population is going to be 7,000. We can also see that from our graph by pressing trace, which is F1. We press trace, and we want to know what's the population when time is 0. So if we type in the number 0, it's going to take us there, and we have P of 0 is 7,000. We must answer in the context of the problem. The context is mosquitoes. You know?
My calculator's on the side.
A quick squeeze. Make sure everyone's on the same page so we can all do the G solving for you. Oh, just change it to radians. Okay, so that's part A done. Part B, determine the estimated population after 6 weeks. So this means, okay, when time is 6, what's the population? So now we're finding P of 6. And the fastest way is still if we're in trace and we type in the number 6, we've got 8,414.2, but we'll just keep it as 8,414 to the nearest mosquito. So F1 for trace, and then we type in the number. We want to know when X is 6, when the time value is 6.
Oh, yeah.
All right. I'll talk about part C quickly, and then if we've still got an issue, I'll come see it. So in part C, it says, what is the maximum population and when does it occur? Well, we already established what the maximum is going to be. We know it's 7,000 plus 2,000. The highest it's going to be is 9,000. All right. Now, the quickest way to get that from our graph is we can press G solve, max. Okay, we want to know what's the max, and it gives us a time value. Time is 4 weeks with 9,000 mosquitoes. Mosquitoes. All right, still okay? Andrew, good?
Yeah.
So we press trace, and then just type in the number. I'll press it again. And type in the number 6. Yeah. There we go. So that's where we got 7,000 and 6. We times 6, the population is 7,000.
So then how does it equal?
Oh,
Feels like 2 tables in your book.
let's see, what's going on?
Like
Oh, because you've got pi x on 6 and on 8. Lincoln, you're good?
Yeah.
Yep, 3, okay. All right, so that's part C. Let's go to part D then. When is the population 8,600 mosquitoes? So for this one, there's 2 strategies that we can do. All right. The first one is to go G solve on our graph. We're going to press the across arrow, and there's X calc or Y calc. We want to do an X calc. Why? Because we are asked when. When is the population? So that means what's the value of time when the population is 8,600. So we're going to go X calc, and when the Y value is 8,600. All right, and what do we get? We've got 2 values, 2.36, and we press the across arrow to navigate to our other value, 5.63. 5.64.
Sorry.
You press the cross.
All right, so based on our model, the population of mosquitoes is 8,600 when the time value is 2.36 and 5.64. Okay, so that's the first strategy we can do to answer this question, just doing a G solve and doing a X calc. X calc because we're asked to calculate time. Y calc if you want to put in an X value, it's the same as trace, where trace is much faster. Okay, for part E says, when is the population of mosquitoes larger than 8,000? During what interval does the population exceed 8,000 mosquitoes? So if here's our mosquito thing, right? And the principal axis is 7,000, so that's the principal axis. Here's 9,000, that's the most. 8,000's here somewhere. And so we want that interval of time. That's what it means from the graph. Now, I reckon the best way to do this is to exit out, and we have y1, and then we're going to sketch y2, which is just going to be the line 8,000. Horizontal line drawn at 8,000. So we'll sketch that, and you can see both. Okay. Now we can really easily, we press G solve, intersection. Okay, corresponds with F5. and we've got those two time values for part E. We have time is 1.3 recurring, and then we use the across arrow to navigate to the second one, 6.6 recurring. Okay, so to answer the question, it says, during what interval does the population exceed 8,000? We would say between 1.3 weeks and 6.6 weeks, the population exceeds 8,000 mosquitoes. So it might be when there's more than 8,000 mosquitoes, you have to take your Mozzie spray. Okay, so that's part E. And then for part F, now normally with this kind of question, we'll probably get you to graph early on at the start so that you're using the graph to answer these later parts, all right, because we're just using the model. But as far as what features are required for the graph, you're going to need everything. So again, when we get you to sketch it, we'll give you an axis, okay? And what's good about that is whatever V window we give you on this axis, that's what goes in your calculator. So it'll go from 0 to 16, and you'll have a max at 9,000 here. And if we're just going to sketch it, you know, so 7's about there, 5's about there, and it's doing this kind of thing, isn't it? It's going up and down and back up in 16 weeks. And so a couple of key things that we need, we're going to need each point to correspond in its correct position. So for example, we have a population of 9,000 at 4 weeks. You know, so there, 4, 8's about here, I suppose. 12's about there. So we're getting all that scale correct. We're going to label the function. So we have to have P of t equals 7,000 plus 2,000 sine. All right. And if we've got the shape and we've got a nice scale, we've got all of the things that are required. 5,000 there. It'll be the lowest that it goes. Okay, any questions about generating a nice graph? Or basically graphing, right? Graphs tend to be worth about 3 marks. They're like some of the easiest 3 marks you can get, right? You're copying from your calculator. All right, so don't stuff it up, make sure you get it right. Make sure you're labeling your axes, you're labeling the function, okay, doing those extra things. The way we mark a graph is we have grid paper, right? And basically there'll be about 4 squares. So there might be 4 squares drawn around there. And your max needs to occur within those 4 squares. Okay, so that means you're going to get the mark for that one. And then down here there'll be four grids there. And as long as your minimum points occurring in that region, you'll get the mark for that one as well. Okay? So that's how we're allocating marks when we're doing a graph, is talking about the key points or the critical points of the graph. All right, really good. So that's going to be plenty for us to get stuck into this exercise today. Today we've just got the exercise 7F, and then I've got some revision materials to hand out for us to start looking at revising for our test next Monday. So 7F, let's have a quick squiz. E2, 3F. Yep. So yeah, there's 4 questions there. Just on your calculator, using your calculator, go through and solving them in radians for all of them. And yeah, some good problem solving skills.